applications, because now you might even say, you know, Mr. Judge, the thing about that math is, gosh, we never get to see how we use it. Why do we even learn what we're doing? You know, is this like a game like playing checkers or chess, and that's all we're learning how to do? And I'll say to you, no. You know, part of what we've done in this course was focus on the applications, and that's near and dear to my heart because of the fact that this is really why you learn the mathematics. Okay, let me say that again, because that's can be kind of, I don't know, intimidating for some people. They get, you know, I don't want to deal with applications because they have words. Well, yeah, they do, but how else can you communicate to somebody an application without words? So let me say this to you guys. You guys remember, these vectors, any vector v, remember what the definition of a vector was, right? A vector v written in ij form, okay? This is an object that has what? Magnitude. What's magnitude? Well, it's length. And it has what? Direction. And you say, well, what's direction? Well, that's that angle theta. So, you know, we've been going through the details. We've even been coloring the horizontal component green. We covered the vertical component, what, blue. I and j vectors were the unit vectors for this vector v. And so we've been going through a lot of these definitions and work with magnitude and what? Direction here, okay? So just to kind of share that with you, here's your vector v, has magnitude and direction. And so very often you might say, well, when you deal with an application, what does this really represent? And I say to you, because there's two quantities, right? There's two quantities, that magnitude and direction theta. This really represents, now let me do this here with the colors, get rid of that. We've been writing that theta, all right? Well, vectors in science very often represent force They very often represent force. And you might say, well, really, they represent force or forces? Yeah. They represent force, and let's kind of write it down that way. Force, generally speaking, or if you have more than one, forces acting on an object. And I should just say, okay, let's leave it at that. So very often, these vectors represent force acting on an object. Now, you mean to me, forces can have what? Magnitude and direction? Yeah. They can have magnitude and what? And direction, okay? And that's one of the main reasons you study vectors. They're also associated with movement, okay? And I'll say that too. I'm going to note you associate vectors even with some movement. Because with movement, you can also have magnitude and what? Direction. So the world of vectors is actually exciting, to be, frank about this. So all that work you guys were doing and learning about this was extremely important here, right? We're dealing with this magnitude and direction. Now, let me say this to you guys here, if I can do this here. Remember the idea here. We care. Here's the one thing that we really want to remember, the definition here, okay? So I'm going to say this to you guys. I'm going to give you guys this definition again. I'm going to say let F1 F2 dot 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 up to Fn be really vectors. And they could be force vectors or movement vectors. They're just going to be vectors. Then we say vector R, which is the sum of those vectors. Okay. What was this called yesterday? It's called a what? A resultant vector. And then this is our definition here. This is the definition of a resultant vector. R for what? Resultant. So by simply adding any number of vectors, that vector sum is called a what? That's called a resultant. And so this is actually really what we're really looking for very often when we add vectors here. Okay, you guys okay with that? And you go, okay, here's the deal. Here's some vectors. Now, if I go back to the original notes here, right, what I'm going to do here is this. Where's my notes here on vectors? There we go. Go back to the original notes, all those things. I'm going to go back to, remember I said I was going to get back to this idea of a vector sum? Doing vector addition here. Let's get rid of all of that distraction. Oh, it's called a resultant vector. We said, yeah, this is a free form. Okay? So I'm going to focus on this right here. Again, this portion here. The vector addition. You're given two vectors. And I'm going to share with you guys a very important idea about vector addition. Now, this is just two vectors here, right? You say, and what colors did we use? Blue and, I don't know, what is that? Purple? So you have a first vector they gave you here. In blue, vector V. And then in purple, they have vector W in my picture here, okay? And yes, you have components. And yes, we learned that we can add these vectors by simply adding the components of the vectors. All right, fine. But let's now focus on the graphical picture here of a vector sum, okay? That in blue, here's my first vector here. Calling that vector V, it's kind of like thinking of it as the geometry of the vector, okay? So here's my vector V. Here's that picture. In vector V, by the way, this point is called the initial point. Is that true? For vector V, the starting point. If you guys remember that. And then this is called the what? Terminal point for vector V. Well, you have another vector called vector what? W. Here's your vector W, okay? Now, notice what I'm going to say here about this for vector addition. We can perform vector addition freehand. Okay. Freehand. By using the terminal point of the first vector. You say you're going to have to use the what? Terminal point of vector V, that first vector. You say, what do you mean? Here's a terminal point of the first vector. Would you guys agree with that? So all you got to do freehand addition is align. You say align what? Align that terminal point with the initial point. The starting point of vector what? W. And you go, what? Yes. So in the picture, notice what we just did. For vector W now, here's what they mean. We align the what? Those 2 points. That's the initial point of vector what? W. Just put them on top of each other. So, with vector W now, you say, well, vector W has its own terminal point, and we know that. Been working with those. This here is the terminal point for what? Vector W. So this is what we're saying, okay? Now, when you do this, you create what we call is the resultant. You say, what do you mean? What's the resultant? Well, you see this black vector here? That's called the resultant vector. This is that vector R that we looked for yesterday and I gave you today. So we can say R equals this. This is the vector sum. This is known as the resultant. So in some texts, what they'll say is for this vector, for the resultant, it has the initial point of the first vector. Let's get out a red dot. Has the initial point of the first vector, and it has the terminal point of the second vector. This is called a what? Resultant vector. So you formed a vector sum, graphically freehand. Now they call it freehand, ladies and gentlemen, because what you're free to do is move this vector how? You can move these things any way you like. That's why they call it freehand. So what I'm going to do here is this. I'm going to copy this here for us. If I can, I'm going to go back to the Scratch here. And show you kind of a picture here. Let's get rid of all these here. Because you guys can go back to the video, right? So in blue, we say this is vector what? Vector V. In purple was vector W. And we have to do it this way to create vector, the resultant vector. V plus W. This is the resultant. Okay, we'll keep those very special points. But what you also can do, since this is freehand, ladies and gentlemen, what they mean by freehand, if I can get this, I can move this vector anywhere I want. I am free to move vectors. I can move my vectors anywhere. So it was originally here. And since I'm free to move it anywhere, I can even just say, hey, guess what? Here's another vector. It's the same vector, by the way. So this is vector W, since I can move it anywhere I want. Okay, I can move them anywhere I want. I can even take that blue vector, move it anywhere I want as well. And I'm going to move right in here. And what I want you guys to notice that there is something very, very special here. Okay? So this again, this is another vector. I can move them anywhere I want. But remember, what's a vector? It's an object that has a particular magnitude, length, and direction. So what I did is, notice if you move that vector, as long as you keep the same magnitude and direction, okay? Here we go. As long as you do that, keep the same magnitude and direction, ladies and gentlemen. I don't even know what color to use anymore. Here, here, here. Maybe we use black. As long as you preserve magnitude and direction, you have the same vector. And that's what we did. We didn't change directions, and we did not change what? Magnitudes. So what you guys are looking at is an extremely important picture. You say, what's this a picture of? Well, let me collect these points here and ask you a math question if the iPad cooperates. Sort of. Anybody happen to know what's that? What is this a picture of? It's not a rectangle. It's kind of like a slanted rectangle. What's this known as? This is a parallelogram. In fact, this is called the parallelogram law. It's a law for vectors for vector addition. So this is the freehand version. This is known as your parallelogram law. And you got to be very careful here, okay? Because you have to have the initial point of the first vector with the terminal point of the second vector, and you're going to create that vector sum. Notice this. This is vector v plus w, and that's known as our parallelogram law for vector addition. Put it down here. Okay? I can move these vectors anywhere I want as long as I preserve magnitude and direction. And you're going to create this vector sum. Parallelogram law. All right, so take a look at this. This is going to be important here for us. Okay, really, really digest that. That's a parallelogram. Called the parallelogram law. So now you might say, okay, Mr. Judge, what does this have to do with, you know, the worksheet you created for us, or I should say, yeah, that's on the website, the vector applications. Well, here's the idea behind it, okay? Remember, a vector is really the sum of forces, if you want to think of it that way, or it represents the sum of some movement to some degree. Has to have magnitude and direction. One of the very most fundamental applications of this comes from the very famous heading and bearing. You might say, what do you mean heading and bearing? Now let's find any potential typos in this, worksheet here, right? So let's read this here. You see, you have an airplane that heads north 60 degrees, what? East. This is the direction. Is that true? Do you guys remember how he did that? Northeast, 60 degrees. So in this picture, and this is the airplane. The airplane, which I labeled in the picture, is blue. It's that blue vector there. So when they say north 60 east, okay, they mean that this is the angle right here. Do you guys remember how heading and bearing worked? You got to go northeast, north 60 degrees east. Okay. And what's the speed? 600 miles per hour. So that's represented by a vector. Because it has what now? Magnitude and what? Direction. So the blue arrow is a vector. Okay, does that look kind of familiar? It should. And that's our heading and bearing. Now, what do you guys know what's happening? And that's relative to the air. You say, what do you mean relative to the air? Well, that's just with the air without wind. So when they say relative to the air, this is the heading and bearing without air. I'm sorry, without wind. What they're going to do now is they're going to define for you a wind vector. The wind blows how? In the direction of. This is the wind now. It has direction north what? 45 degrees west and what? It has magnitude of 50 miles per hour. So what I did here is I drew another vector representing the what? The wind. Now, the truth is, the wind, if I can copy that vector, and I can't, the wind is blowing how? As long as it has that same magnitude and direction, the wind is blowing on your vector, on your airplane vector in blue. So I just want to let you guys know that's kind of the wind idea. We took one of those winds and we said northwest. Well, what's that angle? 45 degrees? That's 45 degrees. That here is the wind vector, the direction. This is the airplane vector without the wind. Okay, you guys okay with that? I don't like how that came out. So this is a 45-degree angle right here. That's going to be important for us. Okay, so that 45 degrees, I should probably move that if I can up closer to the other axis. Fine. So this has a magnitude here as well. Okay, so I'm going to put my notes down here. So I'm going to say this, airplane A, we know airplane A has a magnitude of what? 600. Okay, the wind vector has a magnitude of what? 50. That's what they mean when they say 50 miles per hour and then 600 miles per hour. A is for the airplane. W is for the what? For the wind. You guys see what I'm saying? Now you might say, this kind of seems a little bit like yesterday. You go, what do you mean? Well, the first question is going to be, can you find the velocity of the airplane as a vector? In other words, can you give me, what they want you to know for the first question is this. What does this have to do with yesterday? Can you write vector A for airplane? Okay. They want the vertical and horizontal components. So we need to write it as, I don't know, let's say, I think we have that, it's a bad letter, I don't know. Let's say xi plus what? yj. I just changed the letters because I already have the letter A taken. And for question 2, you say, what are they asking here? Well, find the velocity of the wind as a vector. You go, oh, what? W. A different x, I, and a different y, what, j. Okay? So the first 2 questions are saying, can you do the work you did yesterday? And you say, yes, I know how to do that. This is what we did already. What do you guys need in order to get those vectors, though? Anybody remember? Don't you need what? Theta for the airplane. And don't you need what? Theta for the wind? But you say, do we have them? And I'll say, you sort of have them. Let's move them down here because we're out of space. So what are those 2 values if we're going to write these as ij vectors? Because that's what they're asking. Can you write it as an ij vector? Yeah. Well, how do you get those angles? You see, even though they gave us north, south, east, and west, ladies and gentlemen, do you recognize why we wrote it the way we did? What does this kind of look like? Does anybody know? Yes. The x and y what? Axis. You guys see what I'm saying here? Now y, this is like the x-axis, this is the y-axis. So we need the standard angle, and let me write this vector straight. We need the standard angle. How do I get the standard angle for the airplane, the blue vector? What do I mean by the standard angle? You guys remember? It's like you're looking at an angle with a positive x-axis rotated how? Counterclockwise. What's that positive angle? Does anybody know? It's not 60, is it? Isn't it right here? Isn't it the angle for the airplane is what? Can you guys tell me what that angle is? Is that 30 degrees? So this is 30 degrees, ladies and gentlemen. And that's for the airplane. So that 60 degrees and the 30 degrees, aren't they complementary? Oh my God, I'm going back to day one. Complementary angles. I guess you do need a little geometry here, right? So that's 30 degrees. So ladies and gentlemen, we already have theta for what? For the airplane in blue. Now, can you give me, let's see if you're really awake. You might say, Mr. Judge, I'm never awake this early. I'm going to put that right angle there for quadrant 1. What do you guys remember this angle is here for the wind? Right in here. This is supposed to be 45. Is that true? So what do you think the wind angle as a standard angle is? What's that going to be? Isn't that going to be the 90 degrees plus the 45 degrees right in here? Isn't that true? And what does that equal? 135 degrees. Is that right? What do you guys think about that? Easy peasy lemon squeezy? Anybody have any questions on finding that angle? So you're going to have to give the standard angle here. Now, here's the good news here, okay? If you said to me, how do I get my airplane vector? Right? The velocity vector for the airplane. Well, you guys know it's the what? It's the length of A cosine theta what? I plus the length of what? A sine theta j. Yes. And then how would you get the wind vector? Same what? Yep. Same way. But you got to use the different what? Magnitude and the different direction because it's a different vector. So this is why you did what you did yesterday, ladies and gentlemen. You just have to know that the magnitude of A is what? 600, and the magnitude of the wind is 500. So you're going to write what down here? 600 cosine. What's the direction for the airplane? 30 degrees. Okay. Plus 600 what? Sine 30 degrees what? J. So yesterday, we found the horizontal component in green and the vertical component in what? Orange. And you might say, well, what about the wind vector? Well, what's the magnitude again? 50. What's the direction? 135. So 50 and 135. So this is where you guys get out your calculator and remember the work you did yesterday. So the work you did yesterday, remember, and we want to probably approximate to the tenths. You guys good with that? Let's go out to the tenths. You go, okay, so let's wake up the TI. So, all right, TI. Say good morning, TI. But this is the reason why you do some of the work that you did. And this is from yesterday. Okay, so we're going to start off with what? The 600, with the 600 cosine 30, 600 sine 30. Let's double check the mode first. Yes, we're in degrees. Okay. 600 cosine what? 30 degrees. What does that give you? 519.6. Okay. And then 600 what? Sine of what? 30 degrees. What does that give you now? 300. Okay. I'm going to write this in the iPad. 519.6 I plus what? 300 what? J. So, ladies and gentlemen, you have done your first what? You have found the horizontal and vertical components of your what? Airplane vector. Horizontal in green, vertical in what? Orange. And notice that's a quadrant 1 vector. You go quadrant 1 if we look at it this way, okay? Both the horizontal and vertical components, the xy values for that blue vector are positive. They're in quadrant 1. That's no coincidence. Okay, you guys see that there? That's what you guys have to do. Maybe it's easier to see this way. I don't know. That's the blue vector. It's your airplane vector, okay? That's without the wind. Now, let's get the wind vector. 50 cosine 135, 50 sine 135. 50 cosine 135, close that. 50 what? Sine 135, and you close that. What do you get now? Look at this. Let's go out to the nearest tenths. What's it going to be? First one is negative 35 point what? 4i, and the second one is what? 35.4 what? J. Green and what? Orange. That is your wind vector, ladies and gentlemen. So you might say, okay, the x value is negative, the y value is positive. Isn't that wind vector in quadrant 2? And the answer is yes. You can see it in quadrant what? 2, because the x value is negative and the y value is positive. It's just a small vector and it's covered up. I don't want to erase everything. But isn't that wind vector in quadrant 2? So it makes sense, doesn't it? See if you guys mean, what is the point I'm making? Right in here. All right. Now, the last question is this. Not the last question. The next question. Find the true velocity vector. You say, what? What do you mean by the true velocity vector? I think we colored it what? Oh, it's black. Okay. When they say find the true velocity vector, what do you think they mean by true? It's a true velocity vector of the airplane. What they mean now is include the wind. So if you guys don't know, the wind can be thought of as a force acting on the airplane. So you're thinking of this as an airplane force and a wind force acting on it. Now, what do I mean by that? Isn't the wind pushing the airplane? The answer is yes. So if the wind pushes the airplane, guess what it's going to do to the airplane? Isn't it going to, isn't that shifting the airplane? Do you guys know what you're looking at? That's a resultant vector. That's a vector sum. So if you're going to include the wind force acting on the airplane, ladies and gentlemen, guess what the deal is? You're going to have to add those vectors. So for question number 3, you know what they're saying for question 3? I got to erase this. For question 3, they're asking you for the resultant. R is going to be what? The A vector plus the wind vector. So your resultant vector will be simply adding those two. And there you go. Easy peasy, lemon what? Squeezy. The resultant vector is A plus what? W. It's your vector sum. So now you say, well, how do I get that? Well, take A and add it with W. This is what you did yesterday. 519 point what? 6I plus 300 what? J, this is A, plus that negative 35.4I plus 35.4 what? J. So you're going to add the green components. So the green, 519.6 minus 35.4. I'm going to go to the TI. What do you guys get? What is the horizontal component? 484 point what? 2I. Now we're going to do the same for the orange, the Y component, right? Or the J vectors. Oh, that's easy. I don't have to use a calculator. What is 300 plus 35.4? 335.4. So here's my horizontal component, and then here's my what? Vertical component. Ladies and gentlemen, you're looking at the resultant vector. That's the true vector, I should say the true velocity vector of the airplane when you include the what? The wind. This includes wind. It's the wind is a force acting on the airplane. You just included the wind. So that question is, yeah, you're finding the velocity vector of the what? Of that airplane. You know, it shifts the airplane, ladies and gentlemen. Everything is shifted. Is all of this distracting, ladies and gentlemen? Should I just what? Go, Mr. Judge, can you get rid of all of the sketching? Did you guys see my point? This angle here, though, at 45 degrees is right in there, so you guys know. Okay? So the airplane does get shifted. Because the wind is a force acting on the plane. Next time you get in a plane, remember that wind acts on it, and it has an effect on that. And this is realistic, ladies and gentlemen. So what's the last question though? You got the true velocity vector, the resultant vector of the airplane. What's the very last question they ask now? Notice these questions here. What is the true speed of that same airplane? And it's true what? Heading and bearing. You see, once you get that vector, R, the resultant vector, how do we represent the true speed? How do we represent the true heading and bearing? You know what they're asking for? Go back here. So what are they asking for? You know what they're asking? This is code for saying, what in the world is the magnitude of what? Vector R. And you're going to have to find the direction theta. Now, let me give you guys some information here. I got news for you. That's the theta they're asking for. And let me be more specific. This is north theta what? East. That is the heading. And it's for the black vector. Isn't that northeast? So maybe we should change that letter. And you go, oh, okay, that's I got to change this letter here. I'm going to change it to what? Alpha. You say, why alpha? Because I can get the standard angle theta by using what? Tangent theta wasn't that B over A? Do you guys remember that? And then how do I get the magnitude? Wasn't that the square root of what? A squared plus B squared? But then you might say, but Mr. Judge, you just changed this to X and Y. Okay. Then Y over X, and then what over here? X squared plus Y squared. You guys see my point? Okay, so I'm going to have to copy this. Let's find the magnitude. And let's go to the tenths. What do you guys think? You guys ready? Here we go. Second square root 484.2 what? Squared plus 335 point what? 4 squared. Do we enter everything okay? Could you guys see that? So double check, right? Do we have everything okay? 44.4 squared plus 335. Is that right? You guys see it? All right, here we go. This is 589 miles per hour. Because if you go to the tenths, that zero's in the tenths position, digit to the right's a 1. This is 589 mph. So, ladies and gentlemen, this is a big deal for you guys. This is the true speed of the airplane, and that is when you include what? The wind. So that wind does have an effect on the what? On this airplane, doesn't it? You guys know what I'm saying? The wind has an effect. Now let's compare that 589 to the original 589. Remember, originally this airplane was traveling at 600 miles per hour. That's without the wind. But the effect of the wind on this airplane is what? 589 mph. It slowed the airplane down. Yes?
So what exactly is the answers for like the method of doing part 1 and part 2 of that question?
It's what we did yesterday. You say, what do you mean? You need the magnitude of the blue vector and the direction.
Oh, so it's thing sine as cosine?
Yep.
Okay.
It's right here that we just put in our notes. It's writing the horizontal and vertical components. You're writing that as a vector, an ij vector. How do we get the alpha value? Because remember, what we're saying is this definition is going to give us the what? Theta, the standard angle. So I need theta, the standard angle now. And so where's our scratch? Let's write that down. Here we go. Here we go what? Tangent theta is going to be what? Y over x. Or tangent theta will be 335.4 divided by 484.2. Okay? And what that now means is theta is going to be inverse tangent of what? 335.4 over 484.2. What's that going to give you? We're going to go to the nearest whole angle, okay? Whole angle. Inverse tangent. Second inverse tangent. Is that right? 335.4. Close that. Oops. Sorry, don't close it. Divide 484.2. Close that. What do you end up with? What angle is that? 35 degrees. So this angle is 35 degrees. Oh, that's dark purple. Now that's the standard angle, so be careful. That's your standard what? This isn't the heading and bearing angle you use. That's 35 degrees. So you say standard angle, 35 degrees. What that is this angle right here. Standard angle. Is that the alpha that we need for the heading and bearing? They want the heading and bearing. They want to know what is the true direction. Ladies and gentlemen, this system of navigation is what's used. North, angle, east. So how do you get that? How do you get this? Anybody remember the first day? How do we get that? What's the relationship between alpha and theta? Anybody know the relationship? What's the relationship between that alpha and the standard angle? Aren't they what? What are they? What's the word I'm looking for? What are they? What's that relationship? This is you're putting things together. What are they? Complementary. Yes, yes, 90 minus what? 35. What is 90 minus 35? Because those angles are complementary. You might say, can you put that extra there so I can see it as a, okay, I'll put that extra little arc. Aren't they complementary angles? So what does that mean? 55 degrees. That difference is 55. So here, this is 55 degrees. So here's what we say. This will be north, what? 55 degrees. East. There it is. That's the resultant vector, ladies and gentlemen. So I don't think I wrote down. It's probably, what was the magnitude? Do you guys remember? What was that R going to be? I think I have it still, 589. So, ladies and gentlemen, you have all the information. This is the true magnitude and direction of the airplane when you include the wind. And that's the whole idea. And that's why you learned about vectors, IJ form, horizontal components, vertical components. That's why you learned about magnitude and direction, is so you can apply this in a very real world setting. This is what math is. It's designed to help explain science. Without the math, you don't have a way to communicate the science. Easy peasy lemon squeezy. Only if you did your homework. So if you don't do your homework, you tried all the night before, what's the story? It's going to hurt. You imagine trying to play a basketball game and you never practice playing free throws until the night before. You're supposed to show up and play the game, and then you go, okay, I'm supposed to make a free throw. You imagine that? Isn't that horrible? Anyway, that's how I think about it. All right, ladies and gentlemen, there you go. That's all the nitty gritty. And then you go, Mr. Judge, you give me another example to do here, heading and bearing? Yeah. You give me another one? Yes. Isn't that amazing? Isn't that so thoughtful? Heading and bearing. These are some of my very favorite questions in trigonometry, because it puts all the fundamental ideas together that you learned. And that's the idea. How do you build a house? You need a foundation. What else you guys need? Maybe you have some bricks. I don't know. Then you got to do the plumbing, and then you have the what? You know, the electrical, and blah, blah, blah. You guys know what I'm saying? You got to paint, and you got to put some pieces together. Without those pieces, you're not building a house. So we got to put pieces together, and this is what the whole thing is. So when you're saying an airplane now heads what? This is a little different. What's this heading now? See your airplane again? A in blue. A. The heading is north 60 east. And the speed is what? 600. All right. So let's write this down. What about the north 60 east? What are they doing in blue? You guys remember? This is this angle here. 60. Is that true? However, we need the standard angle. What's the standard angle? Anybody remember? What's the key word again? Complementary. That means the standard angle is 30 what? Degrees. Good. It's for the airplane. This is without wind. Okay. Now, let's talk about the wind. You say, what about the wind? Well, the wind blows due. Oh, this is what I wanted to show you guys. What do you think what do you think due north means? Well, look at your wind. You see the wind vector? You say, Mr. Judge, I don't even see a heading and bearing. They use the word or the phrase due north. You know what that means, due north? That's a right angle. What this means for the wind is we know what? The wind will be 50, because that's what they said. That's the magnitude of the wind vector. But what's the standard angle? 90 degrees. Outstanding. You need to know that. Well, due north, take a look at the vector. Isn't that pointing upwards? That's a 90-degree angle. So they're going to ask us the same questions. Can you give me the velocity vector of the airplane? Yes, we can. Can you get the velocity vector of the wind? Yes, we can. Can you add those vectors and get the what? The resultant vector? Yes, we can. Add. And then could you get the magnitude and direction? Yes, we can. All of this information is what we're going to use. But, we got to use our scratch. Okay. Here we go. You guys ready? Easy peasy. Now that we've seen the first one, we know, horizontal component. Oops. $600 cosine 30. 600 sine 30. We're going to go to the tenths again, okay? 600 cosine 30, 600 what? Sine 30. $519.6. Plus 300J. The wind vector, the magnitude of the wind, cosine theta I plus magnitude of the wind sine theta j. Isn't this what we did yesterday, finding horizontal vertical components? 50 cosine what? 90. I plus 50 sine what? 90j. Zero plus what? So that's 0i plus 50 what? 50j, okay. And 0 times anything is 0, is that right? So you say, I'm just going to write down my wind vector as 50j? Yes. This is a wind vector. So you got the two vectors, and that's what they're looking for. You got the horizontal vertical components for those two vectors. All right, now, how do you get the resultant vector? Here's your resultant vector. You get the airplane vector plus the what? Wind. So, what do you do here? 519.6i plus 300j plus what? 50j. What's that resultant vector going to be? And there you go. And that's what they're looking. This is the true vector here, ladies and gentlemen. This is the true vector of the velocity of the airplane with the what? With the wind, because the resultant vector is taking the A vector added with the W vector, meaning velocity, you're taking the true, well, you're taking the velocity of the airplane without the wind, adding the wind force together with it, and you get the true, velocity vector for the airplane now with the wind. So this is what I'm saying. This is now with the wind. So back with that sheet here, this is what you're looking at here, the black vector R. All right. Now, what do they want again, finally again? What did they say here at the bottom there? Get the true speed. Oh, that's the what? The magnitude. And get the true heading and bearing. It's still going northeast. So what they're going to want again is that north alpha east again. So I want you guys to really be careful with that. Here we go. Here we go. The magnitude of R, you guys know, is going to be what? 519.6 squared plus what? 350 squared. And then we're going to say tangent theta will be 350 divided by 519.6, or theta is inverse tangent of what? Yeah, let's write that all down. Okay, so let's find out what these things are. Second square root, what do we get? 519.6 squared plus 350 what? Squared. What do you get? Go to the tenths. In that 626 point what? 5 miles per hour. So here's the magnitude, ladies and gentlemen. 626.5 mph. So it looks like the wind helped the airplane go faster. Let's find that theta standard angle now. So for theta, second inverse tangent, 350 divided by what? 519.6. Close that out. We get what kind of degrees? The standard angle is what? 34 degrees. Okay, to the nearest degree. Is that true? So double check, ladies and gentlemen. These are the kind of things we want to get, okay? However, that's not the heading and bearing, is it? Right? 34 degrees, that's not the heading and bearing. Which you found, really, is that the standard angle over here, that was 35 degrees. Okay? If you like, you say, oh, this is 34 degrees, sorry. Okay? What do you guys need again? What's this? 90 minus what? 34. And what's 90 minus 34? 56 degrees. And this is in the direction north what? Northeast. North. 56 degrees what? East. What was the speed again? The true speed with the wind? 626.5 mph. So those vectors were very helpful in doing what? Those vectors are very, very helpful in finding the true what? Magnitude and direction of the airplane, the velocity. When you include the wind, notice the wind actually helped the speed, the velocity, the speed of the airplane. It went from 600 to what? 626.5, faster, but it changed the direction. It's no longer what? It's no longer north 60 east. It's really north what? 56 east. This is when you include the what? The wind. And that's why you care about these vectors and learning all the details that we talked about, so you can work with that. Easy peasy lemon squeezy. Did I put the homework on that section for vectors in Canvas? I think I did. It's called homework what? Homework 4. Were there some of these kind of questions there? So, so we'll probably do another one tomorrow. Yeah, see that? We'll do another one tomorrow, and not tomorrow, Monday. You say, do I have lecture on Monday? Sure do. We'll see you guys when? Monday. Take care, stay safe, have a wonderful weekend. Heading and bearing question, okay? So this is what we were working on last time, heading and bearing. Is that true? So I'm going to ask you guys here, what did we do, right? When it says an airplane heads due east at a speed of 500 miles per hour relative to the air. Now, they're referring to the what? This is the airplane, and it's the airplane without the wind. So if it's going due east, this is the vector. Is that true? And then they say the speed of that airplane is what? 500 miles per hour. And so notice a couple of things here, right? Automatically off the bat, we know two things. We're going to let this be our, I should say, A with that line is the velocity vector for the airplane without wind. So they gave you information, and this is without the what? Wind. Okay, you guys okay with that? And so the speed is the length of that vector at 500. Okay, isn't this what we worked on? So could you guys tell me then, what is the angle of that vector? Right? What's the angle of this vector then? And I mean by the angle, the standard angle. What's it going to be? Anybody want to tell me? That final exam is going to come quick and fast. What's the standard angle for that airplane vector? Is that 0 degrees? All right. Now, what does it say about the wind? Let's read this here. This is where we left off. It says that the wind, which is going to be represented by the vector as well. This is the velocity of the wind now. It's blowing what? South 30 degrees east at 60 miles per hour. So this is where your wind is. Okay? And so they gave us a southeast direction. That 30 degrees, again, is where? Right here. This is the 30-degree angle they're talking about, okay? However, that is not the standard angle of the wind, is it? Okay, good. What is that standard angle then? You say, do I have to deduce what this angle is? Yes, that's your standard angle theta. All right, let's write it a little clearer if you guys can see that. So what's that angle going to be? Do you guys know? We're going to have to now let W be that wind vector. And you can see it here. Here's that little arrow. I try to draw it to scale. You know, the length of that W vector, I try to draw it to scale. So what's the length of that vector? Or I should say, what's the angle? Standard angle, what is theta? Anybody know? If that angle right in here is 30 degrees, what's your standard angle? Huh? 300? How do you know it's 300 degrees? Anybody want to tell me that standard angle that we kind of drew right here, that little thing, that's 300, right? How do we know that? How do we know that's 300? 270 plus 30? Outstanding. So it's 270 plus 30. Good job. So that's 300. What's the length of that vector? Which is your magnitude of your wind. What's that going to be? 60. So was this the stuff we worked on, ladies and gentlemen? Is that right? And then, remember, we got to get the resultant vector. Now, what's the resultant vector going to be here? Do you guys remember? Your resultant vector is simply the velocity vector of the airplane without wind plus the velocity vector of the wind gives you that resultant vector. So it is vector addition again here. All right, so here's your vector addition. Okay, so you get this vector right in here. Your A vector plus your what? Wind vector gives you that resultant vector. All right? Adding vectors. Good. So notice question 9 is they want you to get what? That A vector. Okay? Question 10, they want you to get the what? the W vector, the wind vector. And then question 11, they want the resultant vector. And then question 12, they want the what? The length of the what? Resultant vector. And then they want the heading and bearing of the what? Oh, and I guess it's safe to say, if you just look at this picture, that vector is a southeast vector, right? So they want the heading and bearing. So it's south, alpha, east. We have to find those things. So we're going to need to find all of these things, generally speaking. Okay? So does anybody have any questions knowing what we need to determine for this heading and bearing? Okay. So let me try to see. Do we have any space here? I don't know. We may have to, let's write it down, and then we'll bring it into our Scratch. So the A vector, length of A, cosine theta I. We got to write this in terms of the IJ form because it's easier to do our arithmetic, okay? Sine theta what? J. And then your wind vector will be what? Length of the wind, cosine theta I plus that length of the wind, sine theta J. And there it is, ladies and gentlemen. So let's bring some of that information into our Scratch. Is that right? Isn't this what we have to do? Isn't these are the horizontal and vertical component forms of our vector? So in our Scratch, let's find it. Scratch, where are you, Scratch? So we're going to use this information, ladies and gentlemen, to get what we need. Is that right? You guys okay with that? All right. So the airplane velocity vector without the wind, you say, is that 500 cosine 0 degrees I plus 500 sine 0 degrees, this is degrees again, J. Where the wind vector in red now, okay, is going to be your what? 60 cosine what? 300 I plus 60 sine what? 300 J. So we're going to need these components. Horizontal and vertical what? Components here. Okay, let's wake up our TI. Anybody have any questions before we proceed with this? Isn't this everything? Oops, sorry. Isn't this everything we're working on? Is that true? Is that stuff on your study guide as well? And you go, oh, Mr. Judge, did you put a study guide too for me online in Canvas? Did I do that? I did? Wow. Where is it? It's in the module section titled what? Study Guides and Test Solutions. You go, oh my God, you put that there too. Yes, I did. So anyway, ladies and gentlemen, it pays to know what you're doing. Is that right? Good. Okay, and speaking of knowing what we're doing, let's go to the mode and make sure we're on degrees. Are we on degrees? Looks like we are. Okay. All right, let's get to work. 500 cosine 0. And then you got 500 what? Sine 0. So, ladies and gentlemen, that first vector, A, you find to be what? This is 500I, and you say plus, is that 0J? And I'll say, yeah, but what does that even mean? That means it's just 500I. There's your vector. So, ladies and gentlemen, here you go. That's what we're looking for. That's the vector, 500I. Now, that makes sense because this only has a horizontal component. And if I look back at the picture, you know, we only have a horizontal component. So I'm going to leave it like that. Okay, so here we go. We're going to now have to find the wind vector. So 60 cosine 300. All right, so now I'm going to scroll out. $60 cosine what? 300. And then you get 60 sine 300. Now let's go to the tenths, okay? You guys okay with that? Let's go to the wind vector, tenths. So the first number is 30. That's the horizontal component. And then the second number is going to the tenths. Oh, that's about negative 52. Is that right? Okay. So take a look. This is what I'm referring to. This is what it is here. So I want you guys to understand that we found the A vector, we found the W vector, and then now what do we need? The resultant vector. What's the resultant vector? What's the definition? Yes, vector addition, A plus what? W. So your resultant vector, ladies and gentlemen, I don't even have to use the calculator. It's very simple. Isn't it 530I minus what? 52J? And you might say, how did we do that? How did we do that? You took the 500, the horizontal component for the A vector, and you added that with the what? With the 30 to get that 530. It's right in here. Is that true? And then you might say, well, there is no what? There's like a 0. If you say, what is 0 over here minus that 52? Well, that's negative 52 here. So the point I'm making is we don't even have to use our calculator to get the what? The resultant vector. So, ladies and gentlemen, you're looking at all the information you need here to get your, the resultant vector. That's what they're looking for. So you have your A vector right in here, okay? And then you have the what? The W vector information here. There's your A vector and your W vector information. Now we have the resultant vector. So if we go back and we say, well, what was this? Yeah? What's that? I forgot.
Highlighted in red the part where it's like, 30I plus 52. I don't know, you forgot the 5.
Is there a 5 somewhere?
Yeah, in the, what's highlighted in red.
Yeah. Is it 30 minus 5? I think it's 30 minus that 52. So, ladies and gentlemen, go back again. Let's find out vector applications here. Here you go. Where are you? Vector scratch. There we go. So notice this was question number 9, 10, and 11 here. Okay. So maybe I'll go back and say, well, vector applications. Okay, so we got 9, 10, and 11. Vector A is 9. Vector W is 10. Vector R, the resultant, is 11. What do we now again for question 12? The length of the R vector, and then we need that standard angle, though. We need theta. That theta is going to give us the angle that we're looking for, I should say. If we get the standard angle of this vector, vector R here, I'm going to get rid of this here. We need that standard angle. That'll be the theta for the resultant vector now. Okay. So we're going to need that angle. All right. Now, very easily, we already know how to get the length of a vector, right? The length of a vector is going to be the square root of what? 530 squared plus the negative 52 squared. And I'll go to the tenths again. The angle theta, right, you say tangent theta will be negative 52 over that 530. So if you need colors, right, here's the 530. Here's the 530. Negative 52, negative 52. And again, what's your theta going to be? Theta is that inverse tangent. All right. Here we go. Second square root, 530 what? Squared plus parentheses. And I'm going to scroll way out so people can see. In your calculator, you do need to use that, some of you guys, that negative sign here. So here's negative 52. And square that, and ladies and gentlemen, what do you end up with? That's approximately 532 point what? 0.5, yes. So what you just got here was the true speed with the wind. That's what this represents. That's your true speed, and that is with what? With the wind vector, W. You know, that's the whole idea. Now to get the angle theta, right, you're going to say, okay, second inverse tangent, negative what? 52 divided by 500 and what? 30. And you get negative, let's go out to the nearest degree. That's about a negative 6 degrees, okay? So this is approximately negative what? 6 degrees, because 5.6 going to the whole, it's really not a whole number, it's an integer value because it's negative, right? So, all right, let's see if we can figure this out then. Because you're not done, ladies and gentlemen. Okay, what's the standard angle with that negative 6 degrees? You guys know? What do you do? How do we get that? Negative 6. Let's go back to the picture. Right? You might say, is this negative 6 degrees right in here? Yeah. It's negative 6 degrees. Let's get rid of it. So how do we go about finding this angle here? This is the angle we're really looking for, right? We need to know that angle. That's the alpha. How do we go about this? Do you guys know? Anybody have an idea? Let's put this as a standard angle. Theta is coterminal to what angle? Do you guys remember? What does coterminal mean? Share the same terminal point. So that angle, in terms of a standard angle, is really 354 degrees. Okay, so this is the standard angle. This is this angle right in here. Okay, that's the theta. That is 350 what? 4 degrees here. Okay, and that's what we're looking for. Coterminal. 180 would give us an angle in the opposite quadrant. So we're in the angle in the, we can't get an angle in the opposite quadrant. This is a quadrant 4 angle. Quadrant 1, quadrant. So if you said, why 180? Well, that'll give you in the opposite quadrant. 360 gives you the same angle, but now it's, well, let me be careful by the same. We get a coterminal angle. That's why we studied the coterminal angles. So now, if you know that whole angle is what? 354. How do we find this angle here? I mean, there's another way, I guess. What's this angle right in here? This is really what we're looking for. I forget what color we should use. Maybe purple? How do I get that angle? You guys know what alpha is going to be? There's another way to do this. I could have just said, couldn't I have done this? Isn't alpha 90 degrees minus what? 6 degrees? Isn't that a 90 degree angle there? So what is that going to give you? Is that 84 degrees? Yeah. So this is going to be 84 degrees then. Let me get rid of this and share with you guys that this is an 84 degree what angle? So I'm using geometry because these angles are, what's the story? Anybody know what these angles are? What's it called? Complementary. 84 degrees. Good. We're full circle. So there's the alpha. Here's the bearing, ladies and gentlemen. You have to head south 84 degrees east. There's your final answer. South 84 degrees east. And that's the true heading and bearing, you know. True heading and bearing. And that's of the airplane now with the what? With your wind. Okay? So you have all the information now of what they're asking. Let's copy that. Let's go back to our scratch. So, there it is. That's what they're really looking for, all that information, ladies and gentlemen. So I want to share this with you guys in great detail. Because the what? The devil's in the details. All right, let's go over here now. I want to share with you guys another very, very, very similar question. These questions we're going to go through are very similar. These questions, ladies and gentlemen, are really about finding the vectors here. Because remember, a vector is an object that describes magnitude and direction. So in this question, you got tugboats pulling a barge. And the tugboats, it says 2 tugboats are pulling a barge. Tugboat 1 is pulling with a force of 20,000 pounds in the direction of north 40 degrees east. So here's the vector, 20,000 pounds, north 40 what? East. We're going to make use of that information. And then in green, they say here's another tugboat. So here's tugboat 1. And in green, you got tugboat 2. And what's going on there? That's pulling with a force of 34,000 pounds. And there we go, 34,000 pounds. And what's the direction? South, 75 degrees, what? East. All right, you guys okay with that? So you got these 2 vectors pulling on the barge, and the barge is right here. So that's the barge. And what they want to know now is, what is the resultant force vector on the barge? So they want another resultant force vector. So ladies and gentlemen, here's what you're going to need to do. The resultant force vector that they're asking for here is, you got the first, let me do this here. Maybe T for tugboat force. We can do it a couple of ways. I can say here's the first tugboat, the first vector. Tugboat 1 plus tugboat 2, okay? So I have what? The first vector plus the second vector, giving you the resultant vector. So they're going to want this resultant vector, it's a vector sum again. This is the sum of the forces here. All right, you guys okay with that? Now let's dive deep here into this. Let's dive deep. Let's get some information. Tugboat 1, the blue vector, when they tell you, for example, that this is 20,000 pounds, tugboat 1 looks like this. 20,000. Tugboat 2 now is 34,000 pounds. So there it is here, okay? So here's a second tugboat. That's the length of this vector. And they gave you that information. What you guys need now is the standard angles here. We need theta now. So we're going to get the force vectors. And let's see. What's that angle theta? Can you guys tell me? What does this theta angle have to be? 50 degrees. Good job. So this is 50 degrees. Complementary angles again. Okay, 50. Right? Now, if this vector, I should say the green vector, it's down here, the angle now is what? 75 degrees. Could you guys tell me then, if that's 75 degrees, how do I get the standard angle here for that vector? Anybody know what that angle is going to be? What's that whole angle? Isn't this going to be what? 270 degrees plus 75 degrees? Is that what it is? Is that 345 degrees? All right. Is that true? You say, why? 90, 90, 90, 270 plus what? 75 gives it 345. Okay. So let's use this information in our Scratch to get the t vectors here, okay? And we're going to get the resultant vector. So I'm going to copy this. We're going to go to our Scratch. There we go. So here we go. T1 is the length of T1. Cosine, I'm going to write down the information. Cosine theta I, okay, plus the length of T1 sine theta j. Okay, so we're going to have to get our T1 vector. So that's 20,000 now. Cosine 50 degrees I plus what? 20,000 sine 50 degrees j. And then T2 is the length of this cosine theta I plus the length of T2 sine theta j. But you need those standard angles. 34,000 cosine what? 345 degrees I plus 34,000 sine of what? 345 degrees j. We need this T1 vector and we need the T2 vector, okay? There it is, ladies and gentlemen. Let's get the T1 vector and the T2 vector. Okay, so in our TI, let's see, let's get rid of the other information and say we have 20,000. 20,000 what? Cosine 50 plus 20,000. Oops, sorry. Make sure that's 20,000. Cosine 50. What do we got? Oh, 200. Sorry, I can't see very well. 20123. Cosine. Was it cosine 50? I think so. What is this? Let's go to the nearest tenth, okay? 12, 8, 55.8 I. Okay. 20, 1, 2, 3. Sine of 50. You end up now with what? 15, comma, 320 point what? 9 J. So here is your T1 vector, okay? That's the first tugboat. That's the force vector for the first tugboat. So we're going to need now the force vector for the second tugboat. So you're now going to get what? 34,000 cosine 345. And what do you end up with? Well, 34,000 sine of what? 345. Okay. So you're going to end up here with 32,841.5 I minus 8,799 point what? 8J. So take a look, ladies and gentlemen, at your TI calculator there, or your calculator, right? These are all the horizontal and component form values, I say, that you need. Horizontal and vertical components. And so we write them as a vector, and there you go. Those are the two vectors you need. You see, you need those vectors because ultimately, what do you want? The resultant. Good. So you take T1 plus what? T2. Now, be careful here because I've used different colors, so I'm going to have to, I don't know, what I'll do is, let's go back here. I'll use gray and gray. And we'll use gold or brown here and what? Here. And let me see if I could get rid of that so you guys can see it a little better. Yeah. So we got 12,855.8 plus 32,841.5, ladies and gentlemen. And you're going to end up with 45,697.3 I. Okay, that's double check to see if I did my arithmetic okay. Right? That's the gray values. Let's do the brown or gold now. So double check. 15,320 point what? 9. And that's minus. So you go, oh, I made a mistake. Do minus. Good, minus. 8,799.8. 600 and what? 6,521.1 J. 6,521.1 J. So this is the resultant factor, but let's take a look at the details. Looks like this is our horizontal component and then our what? Vertical component. And let me go back here. Let's do this. Horizontal and vertical components of your vectors, ladies and gentlemen. There you go. Easy peasy, lemon what? Squeezy. So to remind you guys, the process is very, very similar to the wind and airplane velocity vectors. Is that right? Isn't that process very similar to that? Absolutely. Okay, now, what do you think they're going to need now? Do you guys know what they're going to need? They're going to want now, again, the length of that vector, and they're going to want the heading and the what? Bearing. So we're going to need the theta to get the heading and bearing. Those are the questions. If I go back over here to share it with you, it's hard to see, but okay. This is question 14. They want the magnitude now of the force vector and the direction heading bearing though, because they gave it to you in terms of a heading and bearing. And notice this, if my picture is correct, okay, the magnitude of that resultant vector, that's going to be That force vector, that's the length there of that vector. But notice I should say what? If we get theta here, this is traveling north, really, theta east, because that's a standard angle. Is that right? Isn't that the standard angle, the positive angle there? So if I get this, if this picture is accurate, it's a northeast heading bearing with theta. So we need the same information like the wind, and the airplane vectors that we just answered in the past there. All right? It's the same process. So let's get to work. Scratch. That's the square root now of 45,697.3 squared plus 6,521.1 squared. Okay, we need tangent theta again, and that's going to be 6,521.1 now divided by 45,697.3. So let's get this inverse tangent here. All right, let's get to work. Okay, let's try this out. Now, I'm going to scroll out a little bit, okay, so you can see some, but let's clear this out. Square root, ladies and gentlemen, that first value of 45,697.3. We're going to square that plus 6,521.1. We're going to square that too. What's that going to give us? 46,100 and what? 60.2. And that's going to be pounds, ladies and gentlemen. So the resultant force is going to be what you guys see here. This is the benefit of using two tugboats. Not just one, two tugboats. There's your resultant force. Let's see the direction in which it takes things. So you're going to say now, second inverse tangent of 6,521.1 divided by 45,697.3. Close that down, and what do you end up with now? Let's go to the nearest whole angle. What's that going to give us? 8. Is that 8 degrees? Nope. Yep. It's 8 degrees. So this is approximately what? 8 degrees now. So remember, was that northeast? Yes. North, 8 degrees east. That's the bearing. And this is the force, 46,160.2 pounds. All right, you guys okay with that one? Easy peasy lemon squeezy. What do you guys think? Is that process pretty simple? Anybody have any questions on this one? Where is it? Vector applications? Let's find it. Vector scratch. There it is, ladies and gentlemen. It is north, theta, east. There you go. Okay, ladies and gentlemen, guess what? I'm going to give you guys some time to try this out here. You say, what? Yes. Here, this is the exact same process. They're force vectors. But they're going to ask you for two vectors now, okay? Here's F1. What is the force 1 vector? They give you the information written down up here. And let's call this force 2. They're going to want to know the force 2 vector. And then what are they going to want to know? The resultant force vector. So they're going to know R. So they're going to want to know, ladies and gentlemen, F1, F2, and R. You say, what is R? R is the sum of the force vectors. So I want you guys to try this out on your what? Own. Do that with these two force vectors acting on that object, okay? And I'll give you guys some time. And let's see what you get. Okay, sorry about taking your time on that one. We will continue when? Tomorrow, and stay safe. We'll see you guys later. And so we have two forces acting on an object. Okay, the first force has a magnitude of what? Of 100 pounds with an angle of 60 degrees. So I'm going to put that information down here because we're going to use it. The magnitude is 100. The standard angle, 60 degrees. Okay, so now we're going to go to the second force. And the second force in green is 270 pounds. Okay, however, this angle here they're communicating to us is what? It's 20 degrees. So the question is going to be, what's the standard angle? The standard angle is that positive angle there. Okay, so I'm going to put this double line there. So what do you guys think that's going to be? Because the magnitude of the second force we know is going to be what? 270. What's the standard angle now? What do you think? What is that? 180 minus what? 20 is, isn't it going to be 160? Good job. Okay, so that angle is 160 degrees. These are 6 degrees here. So, ladies and gentlemen, that's what we're going to do. Now we're going to have to find the IJ form of these vectors. So, if you like, we can take this into the Scratch. How's that? Okay, we're going to take it into Scratch. So, Vector Scratch, where are you? Let's write this down. And actually, I think that's, let's do that in green so you guys can see this here a little bit better, maybe. Okay. Okay, you guys okay with that? So, 100 cosine 60 degrees, is that right? And this is 100 sine 60 degrees. So if you want to put everything, you can. And that's our F1 vector. Here's I. So let's take a look. These are the two IJ form vectors, right? Horizontal, vertical components. Let's get those vectors. So in order to get those vectors, we're going to have to get out the TI, and the TI is here. So good morning, TI. So here's 100 cosine 60. 100 what? Sine 60. And let's go to the tenths, okay? So the blue vector, the first vector, F1, (50i) plus 86.6j. Okay, so there it is. Here's the F1 vector. Okay, you guys okay with that one? Let's look for the F2 vector. Let's see what that becomes. 270 cosine 160, and that's going to be negative 253 point what? 7i. And then you got 270 sine 160. Oh. And we get what? That's going to be plus what? 92 point what? 3j. All right, ladies and gentlemen, here we go. So those are the vectors, if you guys can see that. That's what we're looking for. So hopefully you guys worked on those. Did you guys get that yesterday, by any chance? Now, how do you get the resultant? What's the whole idea? Add, yes. Or is F1 plus what? F2. Let's get the resultant vector. So to do that, let me highlight a little differently. We're going to add the components. All right, here we go. Let's do the addition, right? 50 minus 253.7. So let's try that out. And you end up with what? Negative 200 and what? 3.7 what? I. And then let's do the other addition, right? 86.6 plus 92.3. 178 point what? 9J. And ladies and gentlemen, here's your resultant vector. And of course, it's a force vector. And what do you guys want to do with this now? Do you guys remember? You need the magnitude and the what? Direction. Okay, so we're going to get the magnitude of this and the direction of that. So, okay. The length of R, square root, negative 203.7 squared plus 178.9 squared. All righty, here we go. Second square root, put this in parentheses now. So I'm going to go scroll out so you guys can see. Some of your calculators, you got to use that negative key. So negative 203.7, close that, square it, plus 178 point what? 207.9 squared. And you get, what's the magnitude? 271 point what? 1. So now we have tangent theta going to be the ratio of what? 178.9 over negative 203.7. And theta then will be what? The inverse of this. Okay, so let's get the standard angle and see what this is. Okay, so we'll put 203.7. You guys can see all of it there. What's our standard angle to the nearest degree? Is that negative 41 to the nearest degree? Is that right? Now, this is not going to be what we give as an answer because they want that answer, that angle to be, well, let's double check. Let's go back and see what they want, right? So, what I'm going to do now is go back to the worksheet. Let's see what they want. They want the resultant force and this angle here. Let's actually draw that. So I guess we have to get all that information in. So let's do this here, okay? Share with you guys what's happening. Scratch. So where's our scratch? There we go. Oh, no, that's vectors. Let's get our scratch. Okay, so let's get the other piece of information. So where is this vector? Negative 203. Remember, this here is the horizontal component. So that's the x value. This is the vertical component. There's your y value. So when x is negative 203 and y is positive, you're going to the left. Let's get the right. Negative 203. Now, this isn't really... We don't have any dash marks. So I'm going to kind of eyeball it and say this is where that negative 203 would be. Okay, if we extended this as an x-axis, negative 203 point what? 7. So it's like negative 204. And then we extend the other as a y-axis. That's y, 178.9, which is about one. This might be maybe right here, right? 178.9. This is just eyeballing. And in all honesty, it doesn't look like it's going to be to scale. So let's kind of move this a little bit more if we can. I don't know. And let's draw our what? Let's draw the arrow. And here it is. Well, let's kind of draw that point, the terminal point. Okay. Let's draw that arrow. So this is A, and maybe, let's actually be a little bit more to scale. I apologize to you. I'm a little bit, kind of want to be a little bit more accurate. Maybe 178.9 here. We'll get rid of this angle. We'll get rid of all the highlighting. And the 200 certainly could be more this way. All right, and so that point, maybe this looks a little better. Not quite sure. Okay, so I want you to remind you of something here. This is that resultant force vector. And what I also want to say is, what quadrant is this in? What quadrant? Do you guys know? Quadrant what? 1. Quadrant what? 2. Quadrant 3. And quadrant what? 4. So if this angle is negative 41 degrees, what they're saying is this angle here is what? Negative 41 degrees. Is that true? Right? It's a negative angle. It's in the opposite quadrant. So how do I get the actual angle, the standard angle? Anybody want to tell me? The standard angle is where? It is over where? Here. How do you get that angle? It's 180. Good. Negative 141 plus 180. You guys know what's that going to be? Is that 139 degrees? That's 139 what? Degrees. So, ladies and gentlemen, there you go, 139 degrees. What do you guys think? Okay, that's your standard angle. So you get the magnitude of that vector. You're going to use this angle here, okay? 139 degrees. It's a quadrant 2 angle. And the magnitude is 271.1. I guess this is in pounds, right? Do they give you the units? Yeah, pounds. Now, this is what happens when you have how many forces acting on an object? You have 2 forces. Now, I want to say something to you guys. The next example is having what? 3 forces. And I do see a typo on this. You might say, what do you mean there's a typo? Well, we already have F1 and F2. So I do have a typo. You have how many vectors here now? 3 vectors. So they added a 3rd vector. So I'm going to say here, let's change this and say, what is the 3rd vector? F3. All right. And what's your resultant vector going to be now? Or F1 plus F2 plus F what? 3. So we need the F3 vector. This is the third vector. And maybe I'll just color it here so you guys can see it. Color it green. Here's our magnitude. Okay, here's the vector. So we need that F3 vector. Of course, what you guys know is that the magnitude of that vector, actually, let me go back. Oh, we already have green for F2. Let's change the color. I apologize. Let's change it to orange. I love that information. £240, is that right? So when they're saying that this is 30 degrees, we need the standard angle. What is the standard angle going to be? Do you guys know? I'll put that as a double. I need this angle here. This is your theta. So what is theta going to be, the standard angle? I can use theta. You know what else I can use, by the way? Just so we know? I can use a negative angle. I can use negative what? 60 degrees as well. Is that true? You guys okay with that? So you have a choice here. You can also use that negative 60 degrees, or we can use a standard angle of what? What's the standard angle going to be? Is that 300 degrees? Is that right? It's theta. So pick your poison. Do you guys want to use the 300 degrees, or do you guys want to use the negative 60 there? It's up to you. Should we use 300? Should be consistent? Okay, so that means our third vector now is the length of that third vector cosine theta I plus the length of the third vector sine theta j. So what's this going to be? What's that third vector? $240 cosine what? 300. 240 sine what? 300. So you're going to get the following. 120i minus 207.8 what? J. Okay, so we got the third vector. So if you said, how am I going to get this resultant vector? This is a new resultant vector. Well, we're going to have to add R1, which we already have, or F1. And we're going to add, I believe, F2, what we already have. You guys okay with that? So if you're really awake about this, this is already the sum here. We already got those two vectors here. So we just have to add it to this R vector. Is that right? So what I'm saying to you is, if I take this, this gray, I just have to add the gray of 120 and then subtract the gold there, and it's hard to see now. So we're gonna have to do that arithmetic to get our new R. So let's do that. Negative 203.7, right, plus what? Plus 120. Okay, so we take that negative 203.7 plus the 120. Negative 83.7 what? I. And 178.9. So we're going to go back and do the gold now. The 178.9 here is now going to be added with the what? With the other gold. The negative 207.8. Okay. Excuse me. What was the first number? Was it 178.9? Minus 207.8. We get minus 28.9. So, ladies and gentlemen, if you added a third vector now, right? This example is saying let's add a third vector to the scheme here. You're going to end up with a new resultant vector. And where is that? Negative 83.7, negative 28.9. They're both negative. So this is going to be in quadrant 1. This is quadrant 1. Quadrant 2, quadrant 3, quadrant 4. If you're going to the left, negative 83, and then you're going to go down negative 28. So .7, and then negative what? 28.9. Okay. And let's call that, let's do this in purple. How's that? Maybe we can see it better in purple. All right. So, ladies and gentlemen, this is the vector. It's in quadrant 2. Okay, that's the resultant vector R. It's the new R. So they need the magnitude and direction. Let's go out, ladies and gentlemen, to our scratch. Let's find the scratch. Okay, so if you want to be kind of consistent with these colors of these components. So let's get that magnitude. All right, here's what's our magnitude going to be, and then let's do the direction again. Since we're going to go to the calculator, and that's going to be what? Negative 28.9 over negative 83 point. What's a negative over a negative? Isn't that a positive? All right, so I'm going to put this as a positive when we use the inverse. Here we go. Okay. Second square root. Let me clear this out, okay? Second square root, parentheses, negative, what, 83.7. Close it up and square it. Plus a parentheses, negative what? 28.9. Close that and we square that. See what we end up with. So this is about 88.5. That's the magnitude. £88.5. Okay. So let's find the inverse function here. Second inverse tangent. What's it going to be? 28.9 divided by what? 83.7. And you end up with, what's the angle? 19 degrees. Now let's be careful here, right? Let's double check. If we go back, let's take all this information in. I'm going to do this here. I'm going to move it down here, okay? And move this down here. Oh. Okay, so let's go here. Let's put this information. So let's think about this, okay? The angle of 19 degrees, does that make sense in your picture here? Does that make any sense? The answer is no. Good, thank you. So let's allow that angle to make some sense here, right? So I'm going to draw this line. I'm going to remind you guys, all students take what? Calculus, okay? What the calculator gave me is 19 degrees there. So how do I get the real angle? Yes, you're going to have to add what now? Yeah, you're going to have to add 180 here. Is that right? So what's 19 plus 180? Right? So you're going to add the 19 plus 180, and what does it give you? 199 degrees. Okay, so there's a 180 degrees here. So it's 199 degrees. So what I'm going to say to you guys, make sure you use that angle. 199 what? Degrees anyway. Good job. Okay, so this is adding a third force vector to the situation. And, you know, what you would do is get all the components, add them, And there you go. Okay, so what I'm going to do now is this. I'm going to do a transition for you guys. And we're going to transition to, if we go to our website, hopefully everything's fine. I'm going to share with you guys an important vector operation.